Hi everyone. Welcome to the webinar. This is Building Robust Data Platform with Azure Databricks. This is the second webinar in a series of 4 webinars about utilizing big data. So today, like I mentioned, we're going to be talking about building a robust data platform using the Azure Databricks. Our speaker and presenter today is Tarun Agarwal. He is the data lead at Motiveworks. He has a ton of expertise in all things Azure, all things Databricks, all things big data. So we're really lucky to have him here presenting, and we're very excited that he could make time in his schedule for us. So without further ado, Tarun, I'm going to go ahead and turn it over to you.
Thank you, Sarah. Good morning, good afternoon, good evening to everybody, depending on wherever you are joining the webinar today. Thanks for taking the time from your busy schedule to join the webinar. I hope all of you had a good long weekend, and with long weekend, Labor Day basically means end of summer. So I hope everybody is geared up with their batteries charged for the last stage of 2020. And I'm sure, like myself, everybody must be thinking and waiting for 2020 to be over and we start fresh in 2021. So with that, let's jump right into it. So a brief introduction about myself. As Sarah mentioned, my name is Tarun Agarwal. I am the data and AI practice lead at Motiveworks, and I help modernize data platforms and you create cost-effective strategies to use data as a strategic asset and enable data culture in the organization. At Motiveworks, we work very closely with the Microsoft team and try to leverage Azure platform to enable digital and data transformations. I'm personally, prior to Motiveworks, have experience working in a variety of financial services companies like Lincoln Financial, Bank of America, Deutsche Bank, and so on and so forth, where I've primarily spent most of my time in a leadership position to enable data analytics in these organizations. Just a brief introduction about Motiveworks. I'm sure most of you are aware of who we are, but just to refresh your memories, Motiveworks is a Microsoft Cloud partner and a cloud solution provider company. We are a company based out of Maryland, just outside Baltimore. We're a company which is born in cloud, and we always have a cloud-first thinking and approach for working with our clients. If we have all the right credentials and certifications to be Microsoft partner in across variety of services that Microsoft offers, we really have work in all aspects of application development, and to really first having organization adopt and cloud environment to really elevate that in current infrastructure, move them into cloud, and start to use their cloud services, whether it's a rehost, replatform, or re-architect kind of strategy. Build application developments using cloud native services and modernize their application stack, and building integrated connected application ecosystem. And last part is help them modernize their data platform, leverage big data, artificial intelligence, machine learning kind of services to build real-time cloud scale analytics on the Azure cloud platform. So like Sarah mentioned, we are doing a webinar around doing big data in Azure Data Services. It's a series of 4 webinars. Today is the second webinar in the series of 4. We have already covered how do we migrate big data workloads in Azure Data Services and generate the return of investment of all the investments that has been made into big data. And today we are going to talk about how do we build robust data platform using Azure Databricks. The other 2 webinars are also listed here. If you have already not done so, please go ahead and register for the upcoming webinars where we'll be talking about other aspects of big data in Azure. So the agenda for today's webinar is going to be looking at how do we build a robust data platform in Azure Databricks. First, we'll talk about building a business case for data strategy. Then we'll talk about how do we create optimal database design, how do we improve performance, and how does Delta Lake technology, that is Databricks technology, plays a very key role in building high performance data platforms. So let's talk about the crux of the thing. How do we really build the data strategy and build a business case for implementing a robust data strategy? As we all of us know, that data is really important. More and more organizations are trying to be data driven, and they want to use data to solve complex business problems. A lot of companies who are still using data warehouse business intelligence environment, then they continue to make investment into those environments. That's really good. At least they get insights into what's happening, but it only goes so far. Data warehouses and BI environments are really focused around transactional data, structured data that tells you what is happening in your businesses, and talks about your sales performance, your revenues, any kind of reporting that you are trying to do. That's really falls under the descriptive reporting that looks into rear view mirror and tells you what really happened. But if the businesses are trying to be data driven, that's only one aspect of being data driven. The other aspect of the data driven are still missing from a data warehouse BI environments. With the growth of the data, as the data is exploding and growing enormously in last several years, data warehouse and BI environments are hitting thresholds and limits. And so how do we get past those limits and try to bring in additional and more data? That's another challenge to be in being data driven. Variety of data, I'm sure you have heard this from in various other talks, structured, unstructured, those different kind of data formats that is available. How do we bring all of those data? And like I mentioned, data warehouse is really focused around solving the structured data problem. How do we bring unstructured data into the same fold is always a challenge. And then a lot of companies and organizations end up creating data silos. They have finance reporting, marketing reporting, sales reporting, and so on and so forth. How do we remove the silos and try to really generate insights from data that is available to us from everywhere else? What businesses are really need to be data driven is looking for beyond the descriptive or the rear view mirror reporting. Try to solve questions around diagnostics reporting, like why certain things happen, not just what happened, not just like my sales PM, my customers are churning, but why are they churning? That kind of example. Predictive analytics, what will happen in future? Will customer churn, or how many customers will churn in future? Prescriptive analytics, like really taking actionable insights from using the data. What based on the customers likely to churn, what can I do to prevent it, right? These are the kind of questions that businesses are trying to answer, which requires a robust data platform. Faster time to market, businesses are running at a very fast pace, so the data analytics platforms also need to keep up with the pace of business and give them the data on time and in the right format and right place to be really make more decisions out of it. And scalability as the data is growing, so that the platform should be able to grow. So these are some of the business needs are there, and which if you're only going to look at data warehouse solution, it's going to fall short. So what is the solution to address business needs and solve some of the challenges? Really, people came up with the technology and the concepts around data lake. So we said, let's collect all the data, whether it is structured, unstructured, batch data, streaming data. Let's collect all of them, let's store all of them, and then let's try to analyze them. That was a great thought. And a lot of people started using Hadoop data lake kind of solution, where Hive was the data lake or the warehouse that is created on the top of the HDFS data layer, which was stored. So the concept was great, the idea was great, but it does not really meet all the needs that business is looking for. It falls short. And some of the challenges that we have seen that are very apparent nowadays on the data lake solution is it does not have atomicity, does not have consistent data, and does not have integrity of the data. What do I mean by that? So as you are running your high workloads and the production jobs fail, it corrupts the data. You cannot really there's not an easy way for you to back out the data that has been already inserted without successful completion of the data. You cannot bring it back to the old state of the data, and then it really creates the consistency problem. So those are some of the challenges that currently exist into data lake solution. So what should we do and how do we resolve it? It all starts with establishing a right data strategy. And before we start collecting all of the data and storing all the data into data lake and then try to solve, we really need to understand what is the use case that business is trying to solve. Are they looking for customer segmentation? Are they looking for market basket analysis, anomaly detection, recommendation engines? Whatever is the business problem that we're trying to see, first we need to establish that and then understand where is the data to support those business cases. For what data sources are available, how much data we have, how often the data is available, and whatever data is available to us to solve, is it worthy to solve the use case? Does it have enough content or enough attributes to solve whether it is a customer's segmentation or a market basket analysis? Do we have the right data set in that data that we have available to it? Is it ready? Does it have a right good data quality, data integrity, and clean data? That most of the time that becomes a problem. And I'm sure in your experience you must have seen that 80% of the time goes around data preparation and only 20% of time is spent in doing data analysis. So understand what is the cleanliness of the data is very, very important. Understand who is going to use the data. Are data scientists going to use the data? Are we looking for business users to use the data? Are we looking for providing the data for business analysts or data analyst or business intelligence kind of developers, data engineer? Depending on who the user of the data is, it's going to define your data strategy. If you're going to give it the data to data scientists, you do not probably need to make sure that you have the data available in the right data model and with the right structures. You are going to slow the data scientists down. Maybe give them the data as early as possible so that they can do their own data munging and data cleansing activities themselves and try to generate those insights that the business is looking for. Versus if you're looking to address business intelligence report from the system, then you need to make sure that you have the right aggregates and dimensions are created so that BI tools like Power BI and other tools can really work appropriately on those environments. So knowing the data, who the users are also a very important part in establishing a data strategy. And last thing is what tools are they going to use? Are they going to use Power BI? Are they going to use Python? Are they going to use some other machine learning engine? Are they going to consume the data in the existing business application? So depending on what the delivery mechanism or the way consumption of the data is going to happen, it also defines a lot of things on data strategy. And a lot of those things actually combines everything we are talking about, not just relational data, that is transactional data that is generating from your businesses. This also applies to everything, whether it is unstructured data, semi-structured data, batch data, real-time data. We have to understand before we start collecting and storing the data into data lake, all of these aspects to really establish a good data strategy that solves the problem and then really becomes a good pragmatic approach as opposed to a philosophical approach. Okay, that brings us to our first poll question for today. And Sarah, if we can have the poll on everybody's screen to see if we can get some responses. I'm trying to understand based on the discussion we had in last 10-15 minutes, what are the main data and the data needs attendees have around the data that they're using. Are they mainly dealing with structured data or unstructured data?
All right, I am seeing the responses trickle in, so I'm going to leave it up for a few more seconds just so everyone has a chance to respond. So it looks like a majority of people are using mainly relational databases. I'm going to go ahead and let Tarun regroup. I'm going to take this poll off, and if you guys have any, if you want to just take your time, if you haven't answered, feel free to answer now. We'll see how the percentages change.
Sarah, can you hear me?
Yes, I can.
I think I lost my connection for a few seconds. Can you see my screen?
Yep.
Okay, I need to go back. From current slide. Okay. Yeah, I got a message that my connection has been dropped. So, all
Yeah,
right.
the joys of COVID. Yeah, so as I was saying, a majority of people said that they're using mainly relational databases.
All right, so I got that part. Thank you, Sarah. So let's move along. Okay. All right. So as we talked about just a data lake as a solution, but the traditional data lakes that are built on Hadoop platform have some limitations around that. Really puts a lot of question marks around the consistency and the integrity of the data. Let's understand how Azure Databricks can solve those challenges and provides you a good foundation data processing system. So Azure Databricks is a Spark-based data processing engine that has been very, very efficient in building data lakes, and not only building data lakes and solving some of the challenges that people have been facing over the years in Hadoop kind of data lake environments. So Spark, I'm sorry, the Azure Databricks really brings forward four key points that is on gives you better performance and environment than Apache Spark environment. One is a Delta Lake. Second is the unified data analytics platform. Third is the Apache Spark engine, which is far more optimized than open source Apache Spark. And the last one is ML Flow. So let's understand each one of them one at a time. So as we were talking about collecting all the data and storing all the data, Spark allows you to create ACID transaction layer on top of your data lake in the technology called Delta Lake. So Delta Lake will give you ACID transactional capability, which is like a relational databases that have atomicity, consistency, isolation level, and integrity and durability of the data. That is available to Delta Lake technology. So as you are loading the data, and if your job fails, you can still see the consistent data from the prior load before that load job failed. So that gives you the atomicity of the data in Delta Lake. And to address who are the users of the data and how are they going to use it, what you can do is build tiered data layers in Delta Lake technology. Typically we call it bronze, silver, and gold. So bronze data is the data that is in a cleanest or the rawmost form as the data is being gathered from the source systems. Typically data enough scientists are going to be wanting to get access to this environment as soon as possible, and the reason for that is they do not need to wait for other transformations and validations that needs to happen to clean the data and make it business ready, they can do their own data cleansing and data munging themselves. So typically, data scientists will go against this. While the data scientists are doing their work, data engineers are taking the data from bronze layer and really cleaning it, filtering the data, removing the bad data, inconsistent data, and augmenting the data with additional attributes to make it a better use for the business users. And finally, for all the BI kind of use cases, we can create the rare layer on top of silver data to create aggregates and attributes and dimensions and facts that can be used for end user reporting, business intelligence, kind of a use case. So that's where you can achieve solution of, depending on who is working, what data set they should be going, and you can really achieve that environment of, instead of having one size fits all approach, give different people the different kind of data layer in the using the data lake technology. The Spark engine, which is the heart of the Databricks technology, is actually much more optimized than the open source Spark, which is available in other distributions. It gives you a lot of on-demand capability of the horsepower. It gives you elasticity to go up and down. It allows you to run production level jobs and workflows, and able to integrate with the other native services of Azure Cloud using Databricks, like Data Lake Store or Synapse Analytics, Power BI. All of those things are tightly integrated in Azure Databricks. And I've given the URL if you want to see the lot of other features of how Databricks is better than open source Spark. You can click on the link and see the detailed breakdown of how Databricks Spark is better than anything else out there. The unified data analytics platform is really the main power of enabling collaboration between the different teams. So using the Databricks workspace, people, whether they're data scientists or a data engineer or data analyst, they all can work as a say common users in the same workspace and platform, and they can share their work. So that gives them the unified platform. And the last one is the ML Flow. So ML Flow is the latest addition in the Databricks, which really allows you to do machine learning at scale. And there are a lot of problems that machine learning users had because of having multiple libraries and algorithms. And a lot of time we end up using different algorithms to improve the performance of the machine learning models. And it becomes challenging of using what tools we need to use. It becomes very, very challenging to track your experiments when you keep on tweaking the parameters and hyperparameters to enable the best performance of your model. How do we track that what parameters or tuning was used into what model becomes very, very, very problematic. The next problem is how do we reproduce results? Since we are unable to track in a traditional environment, reproducing a result of a particular model becomes very hard. And deployment of machine learning models also is a challenging problem. So ML Flow is a solution, that Databricks solution that solves all of these problems. It gives you a tracking mechanism where you can track the various versions and the codes and the parameters used into each version. It allows you to create projects, which is a standard way of packaging the reusable data in the code so that you can deploy the project as a whole. And it gives you ability to deploy models as a package is called flavors. So you can create multiple models and call it as multiple flavors, and depending on what you're trying to deploy where, you can deploy that flavor. So ML Flow solves a lot of those problems that typically people face in traditional machine learning environment. So just to bring all of these things what we talked about together and expand the architecture we saw in the last webinar, as you are bringing in the data, whether it is structured or unstructured, batch or real time, the data is going to gets collected into Data Lake Store, but the data lake will be built in Data Lake technology. We talked about the bronze, silver, and gold tiers of the data, and Synapse Analytics, which gives you the data warehouse layer in Azure Data Platform, we will be copying the gold layer of the data into Synapse mostly for the business intelligence and reporting kind of purposes, and to give you data warehousing environment. And Power BI will connect to Synapse. So that gives you a reference architecture to build a robust data platform, and then how Databricks play a very important and critical role in building this data platform in Azure. So with the data strategy discussion, let's move on to the discussion of how do we optimize the Databricks performance. So Databricks is not just a magic wand that you start using Databricks and it starts to solve all your data problems, starts to perform. So but you can configure and optimize your Databricks environment by using various new techniques, and we'll talk about some of them today. So first thing is, like I mentioned, Databricks has a concept of a Databricks cluster, which is nothing but a CPU machines or the horsepower that's gonna drive give the Databricks environment the processing power. Typically, the more nodes, people think that the more nodes I'm gonna throw at it, it's gonna run faster, but at the same time, it's gonna cost you more. So if you have more number of nodes in your cluster, it's gonna cost you more. If you have higher number of sizing of the nodes, if you have more cores, instead of 4 cores, you move to 8 cores or 16 cores, it's gonna cost you more. If you add more memory to your nodes from 8 GB to 16 GB to 32 to 64 and so on and so forth, it's gonna cost you more money. And so how do we really optimize the performance and optimize the cost? There are some best practices here. So depending on the kind of workloads you are trying to leverage in Databricks, you can use different kinds of Azure machines to make up your cluster. So if you are looking for machine learning kind of applications, which requires a lot of iterative use of data, the same data is going to be used over and over again, and it requires a lot of caching. You should use memory optimized machines in your cluster in Azure environment. Those are the machines with DSV2 machines. Whereas if you are trying to do a lot of ETL kind of jobs and processing of the job, or the streaming kind of a use case, where you really need to process data on incremental row by row operations, and does not really need to join a lot of data together. That means it does not need a lot of memory to perform, but it is CPU bound. So for that, you should go for compute optimized machines in Azure to build your cluster, which is of the SKU FS version V2 SKU machines. But if you're dealing with the very large data sets, the data set that requires very high IO intensive operations and requires high throughput, like if, for example, you're trying to analyze images, or doing some ad hoc queries, or using large tables in Delta Lake, tables which has billions and trillions of rows. And so every time you will be very optimized if you read from cache those billions of rows as opposed to reading from the Delta Lake table directly. For that, you should use storage optimized machines with SKUs LSV2 versions. That's going to give you the better throughput and IO intensive operations on those. So using some of those, depending on what size type of machine you use, you will be able to get better performance and at optimized cost. The next thing is, how do we optimize cost? How many number of nodes or how many number of cores in each nodes do you need? So my advice to you will be, if you start to get it right from the beginning, probably you will be wasting a lot of time. So start with a starting point based on your experience, and depending on the volume of data you are dealing with and the complexity of the transformation, start from a starting point and then use Spark UI and various other metrics available to see how the jobs are performing, how some of the metrics are telling you, and tweak your sizing based on that. My recommendation to start will be probably somewhere around 64 gigs of RAM memory machines. You should start, and then tweak it, go up and down based from there. So one of the options you can use is, if you go to the Spark UI in Databricks, in under storage tab, you will be able to see the data usage and how much data is coming from the cache versus how much data is coming from the disk. And if you see that the data is fully cached, everything is running from cache, then that means you probably have more number of nodes than you need. So that's an opportunity for you to reduce the nodes. That will also save you the cost, and it's not going to affect your performance. The next one is, if you see the data is cached, but it's not fully cached, it is around 50-60%, then maybe you will be able to get better performance by increasing the size of the node. If you are using 16 GB, maybe is increasing it to 32 GB is going to give you the better performance in that kind of a scenario. Versus when you see that you are dealing with large data sets, which is hardly cached, that means the data is so large, it's not fitting in the cache that you have on your nodes. You will be better off using the machines with the SSD disk and cache it on disk. That will give you better performance than trying to increase the size or increase the nodes of your cluster. Spark UI also leverages Ganglia matrix as a part of the Spark UI, where you can track your CPU utilization, your memory utilization, your disk utilization, and you can use those matrices to tweak your cluster sizing. Couple of things, just the tips to improve your sizing is, when you create data frames in your Spark code, this data frame is going to create partitions and parallelism based on number of nodes you have. And a good written Spark application will scale linearly. What do I mean by that? If you double the size of your cluster, it should reduce your processing time in half. So if you are using 16 core machine, and if you go, or maybe like 16 GB RAM memory, and then you double it the size of your cluster, the time it took, if it took one minute to complete the job, it should complete in 30 seconds. That's really the benchmark you should use to see if your application is written good. By looking at some of the CPU stats, if you're seeing that the CPU usage is staying above 80%, that means the driver of the cluster, you're stressing it on much, so you need to address that. If you're seeing a lot of network spikes, then you should use SSD-based machines. And if you're looking at a lot of spills, then you should use higher memory machines. So using the Ganglia matrix can help you to optimize your cluster. So by looking at optimizing the cluster, let's talk about how do we improve Databricks performance further than more than that. So three main topics that really gives a lot of performance related issues in Databricks environment. Let's address it today. One is called shuffle, another is called spill, and third is queue. So these are the three areas which you should watch out for, and there are tricks and tips we'll talk about how do we improve on those. So shuffle is basically a process of redistributing data across partitions. So every time you are using functions like joins or group bys or sorting or disting, coalies, each of these functions cause shuffle operations. And shuffle is actually very, very expensive because it is redistributing the data across partition. You can imagine that a lot of data movement needs to happen for shuffling because of shuffling. So we should try to avoid shuffling as much as possible. Some of the things I think we should watch out for is, I'll give an example on the right. If you're trying to join two tables, the default join, and then you see it is taking a lot of time to complete this query, and you see a lot of shuffling is happening in the code by looking into Spark UI. What you should do is you should use broadcast join, and also review the join order. You should always join the smaller table first, then the larger table, and using the small join order, by you joining smaller table to the larger table and using the broadcast join, you can significantly improve the performance of this query. And what broadcast join will do is, broadcast join will take the small table and distribute it or broadcast it across all the executors so that it will not have to do any shuffling of the data. Spill is another area that really causes some of the performance issues. And what exactly a spill is? Spill is when the data cannot fit in the memory. It will spill it to the disk. That's really the standard definition. And what you will see is, by default, Databricks allocates one core per task. Okay, so even if you have a lot of cores, because of the spill, it will not allocate all the cores available in the cluster to perform the task that is needed to complete the query. And that's the reason you will see that the utilization of your CPU is low, but still your query is not performing. You must be wondering what's happening, why my queries, I have so much CPUs in my environment and my query still takes a long time. So what you should really do is understand how the shuffle affects your environment. So the example I've given them is uh, in this particular query, by using 16 shuffle partition, you can see in the sort details, it was doing a lot of spill, and spill size is 18.5 gigs. By changing the shuffle partition from 16 to 48, the same query completes with 0 spill size, and it will come back in nothing 10 to 20x better performance than the normal. So that's how you can watch out for spill and optimize spill by understanding the partitions. Skew is another problem that affects performance. Skew is when the data is not evenly distributed among partition. It will downgrade your performance because it's uneven distribution. You will see that there is a high spike in your CPU utilization, but then there's a very low utilization. How do we solve for skew? You can solve it by using broadcast join or skew join. And if that's still not working, then you should probably use a different key to partition your data. How Delta Lake plays a role in improving performance. So there are three critical pieces of improvement techniques which are available through Delta Lake that gives you better performance: compaction, auto optimize, and z-ordering. And let's talk each of them at a time. Compaction is what happens is when we are loading the data in Delta Lake table, continuously keep on loading every day on a day-by-day basis, period-by-period basis. Over a period of time, you will see that the Delta table has a lot of files. It has accumulated a lot of files in it, and adding the data in small batches will give you a lot of small sizes data files in the thing, and it affects the performance. So what compaction will do is it will take large number of small files and rewrite them into smaller number of large files. So as you can see in the diagram below bottom right, a lot of data files can be compacted into few large files. That's really compaction is. And you can run the compaction command in Databricks, and it's going to compact the large number of files into smaller number of files and give you the better performance. Auto optimize is two settings in Databricks that you can enable, which will give you a better performance. One is called optimize writes, which is going to be dynamically, it will auto optimize the partitions sizes in Spark, and it will give you a better throughput. And auto compaction setting will start to automatically look for opportunities for compaction, and it will compact large number of small files into smaller number of files. So using this optimized tunings, you can improve your performance. And the last one, which is very important, is data skipping and z-ordering. So data skipping actually plays a very important role in getting the 10 up to 10 to 20 to 100x performance benefits in Databricks. What exactly this is doing is it is going to speed up like queries, which I would call them as a finding needle in a haystack. So if you're trying to look for a data in a large data set, data skipping can really help. So what it does is it will collect, when we are entering the data into Delta Lake table, it will collect the statistics for all the columns. And then these statistics are used to determine which data files can be skipped. And another concept with z-ordering is basically ordering your data files into a multi-dimensional format of data that will preserve the locality of the point. So just to explain, and I know we are running out of time, if you are looking for a chessboard kind of a data set, which has 64 points, 8 by 8, so 8 rows and 8 columns, and there are 64 data points, and you're trying to find data point where x is equal to 0 or y equals to, sorry, x is equals to 2 or y equals to 2. In a linear fashion, it will try to find all of these all the points into this one column and all the points into this one row. Each of these boxes, which is basically a 4 point in each data file, so there are 16 data files in this linear fashion. To get all these points into this one row and one column, it is actually going to read and scan 9 files, data files. And all the other data points available in these 9 files, there are 21 points that we are not interested in, all the red dots. So, but if we are going to use linear, the standard way, it's gonna read, for this query, it's gonna scan 9 files, and it will give you 21 false positive results. But if you use Z ordering, and you can use this command to Z order, what it will do is it will create, instead of 8 by 8 grid for the same 64 points, it's going to create 4 by 4 grids, but each block is actually now a multi-dimension of 4 points. So to get the same data, it is going for the same one column and one row. So it is, if you count number of files it's going to scan, it's only going to scan 7 files as opposed to 9 files. But look at the false positives it is going to read. All the red dots now are only 13. So using this technique, Z-ordering technique, you can optimize the way the data is stored in your data files, and which will give you a far better performance. Just to summarize and bring everything to the closure, Azure Databricks provides you the best data processing engine for the most workload types. It gives you the unified data platform for data engineers, data scientists, and data analysts to work together. Delta Lake technology of Azure Databricks is going to give you the high performance to run your data lake, and with the consistent data. You will no longer have to worry about the atomicity and integrity and consistency problems in your data. You can optimize the performance of your data using the right cluster type, whether it is memory optimized or compute optimized clusters. You can improve the cluster performance by tweaking the configuration based on the usage. We talked about using Ganglia metrics and the Spark UI matrices to improve the performance by looking at some symptoms of your how the data is being used. And then by using the best practices of using Z order, by using broadcast join and other things we just talked about, you can further improve the performance of your code and to get the best performance out of Databricks environment. Okay, so Akara, I know we are running out of time, but let's see if we can squeeze in the last poll question, and we will somewhere come close.
All right, so what I'm seeing is a majority people are using Databricks.
Nice. Interesting. So initially we saw majority of people are using relational, now they're using database. That's nice. That's good to know. Okay, so just to, before we close, quickly some of the solutions available from Motiveworks around building your data platform in Azure and leveraging tech tools like Databricks. We have a cost saving calculator on our website. So if you go to this link, you will be able to calculate the amount of savings you will have by running your big data workload in Azure, and amount of cost you will have to run your big data in Azure. You will get both of them. Just a sample of this savings calculator that we did for one of our clients. Second thing is we have a lot of expertise ourselves in Azure Databricks development, and we can help you gain up to 100x of performance gains and give you better performance architecture by moving your slow performing workloads into Azure Databricks. So if you need some help, please reach out to us and we will be gladly able to help work with you. We also do a lot of workshops to really understand the challenges in your big data environment and help you come up with a reference architecture of migrating your workload into Azure based on the reference architecture that will be suitable for your environment. So if you are interested in working with us, please reach out to us. We can do a 2-day workshop to give you the reference architecture and the migration plan and even the cost of ownership in Azure. And if you are interested in moving the data from your existing workloads in Azure, we can help there. So that brings to an end of our today's webinar. Like I mentioned, today was the second webinar in the series of 4. We will be having this third webinar same time next week, which will talk about how do we supercharge your legacy data platform. All right, and I do not know, Sarah, if we have enough time for Q&A.
Yeah, so I'm thinking that we're cutting it a little close. So at this point, what I'll have you guys do is if you have any questions, feel free to email Tarun at the email on the screen. And we can follow up with those questions at a later date. You know, we're happy to schedule a call or, you know, correspond via email. If you guys have any questions or any specific, you know, problems or anything that you're having that you'd like Tarun's advice on. So, Tarun, thank you so much. And thank you everyone for registering and attending. And I hope to see you guys all at the webinar next week. Thank you.
Thank you, Sarah. Thanks, everyone.